Dear students, there are many applications of definite integrals like finding area between curves, volume of solids, surface area of revolution, center of mass, etc. The disk method is one of the applications of definite integrals to find volume of solids, in particular solids of revolution. I hope you remember the method of finding the volume of solids by slicing using definite integrals. However, let us quickly recall it. Let S be a solid whose cross sections are plane regions. To find its volume, we need two things. Firstly, the boundary values A and B, and secondly, the cross-sectional area A of x at each point x in the interval AB. Then what is its volume? Its volume is integral a to b A of x dx. The disk method is to find the volume of solids of revolution. What is solids of revolution? The solids of revolution is a solid which is generated by rotating a plane region about an axis in its plane. Consider a plane region bounded by x equal to a, x equal to b, y equal to f of x and y equal to c. By rotating this plane region about y equal to c, we get a solid of revolution. What do we get if we cut this solid of revolution at a point x in the interval AB? We get its cross section. It is a circular disk. What is the radius of this disk? It is the length of this line. Let us denote its length as r of x. We know that the area of a circular disk of radius r of x is pi r of x square. So, the cross-sectional area of the solid of revolution is A of x is equal to pi r of x square. Substituting A of x in the formula of volume, we obtain the volume of the solid of revolution as integral a to b pi into r of x the whole square dx. This is the method of finding the volume of a solid of revolution using disk method. Here we need to know two things: the boundary values a and b and the radius of the cross section, the disk at x, r of x. Let us now consider an example. The region between the curve y equal to root x, x equal to 0, x equal to 4 and the x-axis is revolved about the x-axis to generate a solid. What is its volume? First, let us sketch the given region. Consider the xy plane. We can draw y equal to root x and then draw the lines x equal to 0 and x equal to 4. We get the plane region. Here, the plane region is bounded between x equal to 0 and x equal to 4. Let x be any point in between 0 and 4. Then we can see that the radius of the disk is equal to the length of the line segment AB. At A, y equal to 0 and at B, y equal to root x. Hence, the length r of x is equal to root x minus 0, which is equal to root x. Now we have the limit as x equal to 0 and x equal to 4 and the radius of the disk r of s as root x. Substituting these values in the formula of volume, we get volume is equal to integral 0 to 4 pi into root of x the whole square dx. Simplifying and integrating, we get the answer as 8 pi. Now you have learned the disk method. Please try this problem.
Review.